All right, it is 2:15, so we're going to get started here with review 3. We're going to be focusing on triangles today, and I think what's a good goal as we work through this packet is, can you, identify what the relationship is? Always a good idea to summarize, so keep that in mind. Okay, so it says side PQ of triangle PQR is extended through Q to point T. Which statement is not always true? So obviously we want to draw a picture of this. So I want to encourage you to try your picture here first before I draw it there. Can you grab that for me, somebody? Okay, so see if you can draw this picture. Okay. Okay, so side PQ of triangle PQR is extended through Q to point T, which statement is not always true. All right, so we've got triangle PQR, and we've extended Q to point T, like extend this out to point T. So what we're looking at here is, this is what the part that we want to see about this. This is called an exterior angle. And the relationship that we want to understand in this particular question without looking at the two things is that this angle up here and this angle, if we add those two angles together, they should be equal to each other. So the exterior angle, the measure of angle TQR, equals the measure of angle R plus the measure of angle P. Okay. So do we have that as, so the question is, which one is not always true? Well, if this is true, obviously it's not going to be choice 3. Now, if the exterior angle equals both of these two added together, the exterior angle itself should be what? Yeah, so it's got to be greater than R and greater than P, and that would leave us with the last one here, that RQT is greater than PQR. Now, in the way that we drew this triangle, that's not accurate based off of this drawing, but there's another scenario where this could be, where that could be true. It's not always true. Does that make sense? So if we had like if you drew the triangle like this, if this was PQR, then this would be, T out here. That's an example where that would not be true. Okay. So number 2, in the diagram below of triangle ABC, BC is extended to D. For the measure of angle A, it's x squared minus 6x. Measure of angle B is 2x minus 3. And the measure of ACD is 9x plus 27. Now, I know there were some people who were working through the kind of practice Regents exam that we've got, and there's a question on here, and you've been trying to do this without understanding the triangle exterior angle theorem. And you can do that in some scenarios. This one would be a pretty tough one to do without understanding that the exterior angle, so just to refresh your memory from our notes when we did this, we called this the exterior angle, and this one would be like remote interior, and it's called the remote because it's not connected to it. It's not the adjacent angle, and we use a remote to get things away from each other. So we've got x squared minus 6x plus 2x minus 3 equals 9x plus 27. So we have a quadratic equation here. It'd be x squared minus 4x minus 3 equals 9x plus 27. So we would subtract 9x and subtract 27. So you get x squared minus 13x minus 30 equals 0. So how many of you are factor people, if possible? Okay, how many are like quadratic formula? Okay, so if we're going to do the quadratic formula, a is 1, b is negative 13, c is negative 30. Okay, the quadratic formula is written on your formula sheet, so you just plug it in and solve. All right, if we're factoring it, we're looking for the factors of negative 30 that add together to be negative 13. So that would be x minus 15 and x plus 2. So x minus 15 equals 0, x plus 2 equals 0. So we would have x equals 15 and x equals negative 2. Can't have a negative length, so x would be 15. Do you want me to do it with quadratic formula? Okay, so again, we would get the same answers with the quadratic formula. Comes out that way. All right. Okay, so number 3, in triangle ABC, the measure of angle A is 58 and the measure of angle B is 43. If we were to order the length of sides of the triangles from least to greatest, which inequality below would be correct? Well, before I would want to go forward in doing this, I'd want to find what the other angle is. So the measure of angle C plus 58 plus 43 equals 180. So 58, did I write 43? So 58 and 43 is 101. So the measure of angle C plus 101. So the measure of angle C would be 79. So what's the relationship? Is the smallest angle is opposite the shortest side. So I'll use a highlighter here just to help kind of illustrate that. So what is the smallest angle? Angle B, and angle B is opposite side AC. So that would be the short side. Then the middle angle is 58. So opposite that would be BC. And then this would be the longest side. So obviously the picture's not drawn to scale here because it doesn't look like that's the shortest side. So which inequality would be correct then? Yep, number 3 here. AC is less than BC, which is less than AB. Okay. So hopefully, those are questions I think you should be like, please ask me that question, okay? Because it's just a pretty straightforward, kind of a relationship. We're not not a lot going on there. All right, in the diagram of triangle ABC, D is a point on AB, AC is 7, AD is 6, and BC is 18. The length of DB could be. So in this scenario, what we need to remember is that the third side should be, here's the formula, the third side should be greater than the difference and less than the sum of the other two sides. So what are our other two sides? 18 and 7. So it needs to be the difference of 18 and 7 would be 18 minus 7 is 11. And the sum, 18 plus 7, is 25. So our third side needs to be between those two lengths. Another way that you can understand this relationship is any two sides added together have to be bigger than the third side. Okay, now, so which number then, if we include it, would make this whole side here, AB, fit that condition? Again, we got to add it together. So let's try, would 5 work? No, because 6 plus 5 equals 11, and this has to be greater than that. So 5 would not work. How about 12? 6 plus 12 is 18. 18 would make this true. Okay, so it could be that. 19 doesn't work because 6 plus 19 is 25, and again, it's not greater than. Okay. All right, now we're going to get into our Hills and SAS questions. I suggest that one of the things, I don't think there's like, there's a lot to remember. One of the things that I would add to my formula sheet would be a diagram of Hills and SAS. If you haven't done it enough yet where you have it totally, this needs to be on your leg 1, altitude, leg 2, side 1, side 2, and then the hypotenuse. Okay, this is like at a minimum 1 question, sometimes up to 3 questions related to this topic are asked. Yes? It could. This is the shortcut to that, but yes, that's you can separate the triangles. The reason why we do it this way is because what happens to most people is when they're drawing those triangles, they don't orient them in the right way to get the corresponding sides correct, and they set up the wrong proportions. Okay, so Hills could be hypotenuse is leg 1 over side 1, or it could be hypotenuse of leg 2 equals leg 2 over side 2, or it could be side 1 over altitude equals altitude over side 2. Okay, any like specific questions on that? Do you feel like you understand what all those lengths mean there? Okay. So in the diagram of triangle ABC, ACB is 90 and DC is an altitude. So if AD is 2 and DB is 6, find AC. So you have to recognize that this is a right triangle with an altitude drawn. Therefore, this is a Hills and SAS setup question. And what we're looking for, we'll call this X over here, find AC. We'd call that leg 2, side 1. Can we find the hypotenuse? What would the hypotenuse be? 8. We just add them together. So hypotenuse over leg 2 equals leg 2 over side 2. So 8 over X equals X over 2. So this would be X squared equals 16. Take the square root. Algebraically, we'd want the positive and the negative, but because we're dealing with a length here, we just deal with the positive root, and that would be 4. So AC would equal 4. Questions? Okay, number 6. In the diagram below, the length of the legs AC and BC of right triangle ABC are 6 and 8 centimeters respectively. Altitude CD is drawn to the hypotenuse of triangle ABC. Find X to the nearest tenth of a centimeter. what I can't do on here, but what I would do if I were you is I would turn this paper upside down. Because in my head, I view this question much more like that's how I see it. So I turn it upside down to orient it like I draw the picture. You don't have to do that, but so if we did it that way, this would be leg 1, side 1, leg 2, side 2, obviously the whole hypotenuse, okay, and the altitude. All right, now, is there any way that we can directly get that? Do we have enough pieces to directly get this as it is? Like if we have SAS, side 1 over altitude equals altitude over side 2, could we solve it that way? No. If we do a hills, hypotenuse over leg 2 equals leg 2 over side 2. Well, we know what leg 2 is. Our variable is side 2, but we don't know the hypotenuse. So can we find the hypotenuse? The big triangle is a right triangle. When we know 2 sides, we can find the third side using the Pythagorean theorem. So 6 squared plus 8 squared equals, call it h squared. Does anybody know what it is without doing the Pythagorean theorem? Take that as a no. It's going to be 10. It's a 3, 4, 5 triangle. Okay, so like if you're familiar with some of those Pythagorean triples, this is a 3, 4, 5. Okay, so we get 10. So now you can fill that in. So 10 over 6 equals 6 over x. Okay, and it's just a matter of doing the cross product property. 10x equals 36. Divided by 10 is 3.6. Okay. Yes. Yep. Say that again, x plus 2x. You're making an assumption there that we can't prove. So you're assuming there that dB is double the length of x. Okay, and yeah, we don't know that. I don't know what that is. Okay, we'd have 2 unknowns in there. Okay, so let's, why don't you guys try 7, 8, and 9 on your own. All right, so for number 8, when we set this up, this is a side 1 over altitude equals altitude over side 2. When you're trying to remember that, if you say SAS and you hold the A really long, that will help you remember that the altitude has to be in here twice. Okay, so what do you think is the common error people make algebraically when doing this cross product property? Any ideas? That would be one thing. Yeah, they don't distribute it. That's sometimes what I see. Like, so whenever so this is going to be x squared plus 5x equals 36. A lot of times I see x squared plus 5 as a solution to that. So if we subtract 36, again, if you're a quadratic formula person, A is 1, B is 5, C is negative 36. If you're a factoring person, this is a special case since A is 1, and we're looking for what multiplies to be negative 36 and adds to be positive 5. So that would be x plus 9 times x minus 4 equals 0. Okay. Sometimes people who do a lot of math in their head, their mistake in a question like this, especially if it's a multiple choice question, is they'll pick 9 as the answer and not finish out solving it. Like x plus 9 equals 0, x minus 4 equals 0. So x would be negative 9 and x would be positive 4. And we would reject the negative 9 because you can't have a negative length. Okay? So, and since it said find RT, let's just call it RT. RT equals 4. What's that? Yeah, the reason that doesn't work, that doesn't work because when you take the square root of that whole side, you know why that doesn't work algebraically. Okay. All right, we good with 9? Do we need to do 9, or you want to see 9? Oh, good point. All right, hey, it's not. RT is, what did we find here? We found x, which is 4, and then this is 4 plus 5, which is 9. So good catch. So RT would be 13 instead of 4. Okay. All right. That's one of those like good final things when you're doing a question is you always go back and make sure you answered the question, which I didn't do, but which you did. So hip hip hooray. All right, good work on that. All right, let's do 10 because same type of thing. Are we okay? So I just want to answer question A. What is the relationship between the large triangle and the two subtriangles? Okay, they're all similar. Because of the angle-angle similarity, right? So what happens in this is the big triangle and this smaller triangle have those angles in common, and they have a right angle, and then they have this. So if two angles are the same, the third angle would also be the same. So they're going to be similar because of angle-angle similarity. All right, and since they're similar should always lead us to think about setting up what? Proportions, okay? Every time you see the word similar, you should be thinking about proportions. Proportions, again, are two fractions that are equal to each other, okay? All right, so again, we just did a bunch of this, so I'm going to go jump to 11 here. Sarah is building a triangular pen for her pet rabbit. If two of the sides measure 8 feet and 15 feet, the length of the third side could be, well, we did this one earlier, right? It's got to be greater than the difference and less than the sum. So 15 plus 8 would be 23. So what could her length be? 13 feet. Okay. All right, in triangle RST. RST. R is 58. S is 73. So if R is 58 and S is 73, what would the measure of angle T? So if we did the measure of angle T plus 73 plus 58 equals 180. Measure of angle T plus, oh, what is that? 131. Okay, and then when we subtract 131 from 180, we would get 49. Okay, so 49 is the smallest angle, therefore which would be the shortest side. So you draw the angle out on this and you get short over here. So it's RS. So I'm going to eliminate 1 and 3 from it. Then our middle one would be ST because we draw out from angle R. And so that would be choice number 4. All right. Question. Are you at the point where you're like, please ask me this question? Right. They're going to ask questions, right? So like, you know, if you get to pick, we don't get to pick, right? But if you get to pick, right, like this should be in like the wheelhouse of like, ask me one of those ones, okay? All right. What's your name? Who's your daddy? Ooh, ah, ooh, is he rich like me? Has he taken any time? I shouldn't sing that song. I don't really know all the lyrics and what they mean, so we'll just stop there. All right. So here's the deal. It says angle C is obtuse. What do we know about angle C if it's obtuse in a triangle? It's an obtuse triangle. Can any of the other angles be obtuse? So therefore, it has to be the largest angle, and therefore this has to be the largest angle, therefore AB has to be the longest side. There's no other options in an obtuse triangle. Okay, so what else do we know? Well, we know angle A and angle B are congruent to each other. So what type of triangle is this? Isosceles. So those two sides are going to be congruent. So AC and CB. So what choice is that? 2. Okay. Just making sure. All right. Getting here towards the end. So as shown in the diagram of triangle ACD, point B is on point AC and DB is drawn. Measure of angle A is 66. The measure of angle CDB is 18. Measure of angle C is 24. What is the longest side of ABD? Well, all these longest side questions start by first finding what are the angles. So in this triangle, we've got two angles. We know 18 and 24. So 18 plus 24 adds up to be 42. So these add to be 42. And if we did 180 minus 42, we would get 138. Okay, that's this angle. Now what do we have going on here? We've got a linear pair, so therefore this angle would have to be 42. Those are a linear pair. Always ask, what do we know? Well, now what do we know over in this one? We know these have to add up to 180. So if we add 66 and 42, that's going to be 108. And if we subtract from that from 180, it will be 72. So in our triangle in question, and I would recommend, like, if you have a highlighter, bring a highlighter to the exam, because you know it'll help you. That certainly is allowed and is a good idea. So that's the triangle in question. What's the biggest angle? D. We wouldn't really call it D, but we can for our discussion. So therefore, side AB would be the longest side of that triangle. Okay. What's that? So again, if we just look at the triangle ABD, 72 is the largest angle, so longest side. Okay, now we switch gears a little bit and we introduce a slightly different topic here in 15 and 16. And the diagram of triangle ABC below, AB is 10, BC is 14, and AC is 16. Find the triangle formed, find the perimeter of the triangle formed by connecting the midpoints of the sides of triangle ABC. Okay, so what is it called when we connect the midpoints? Do you know what that segment is called? Midsegment. Okay, good. So, midsegments. Two properties that we should think about with midsegments. Number one is it's half the side, and number two, it's parallel to the side. Those are the two things that are asked about. So it's half the length of the opposite side, and it is parallel to the opposite side. So this would be 8, because half of 16 is 8, half of 10 is 5, half of 10 is not 14. I mean, half of 14 is 7. Okay, so the perimeter would be 8 plus 7 plus 5. So that would be 20. If you want to, when you're doing that question, if you wanted to find the perimeter of ABC and divide it by 2, that's another, good way of doing it. And but again, with midsegments, you want to think half the side and parallel. And they seem to like these different types of questions. You may recall on a problem set where they asked you about the perimeter of this quadrilateral here, but they didn't give you specific numbers to find it. You had to do it in relationship to the sides. So they kind of like to throw this in here. Okay, all right. In the diagram below of triangle ABC, we got AE congruent to BE, AF congruent to CF, and CD congruent to BE. All right, so for me, when I see this multiple choice, centroid, circumcenter, in-center, orthocenter, I'm thinking this: PB, CC, 2E double T A B is in, 2E double T A B is in, PB, CC, PB, I got the B in my head, 2E double T A B is in, 2E double T A B is in. Does that mean anything to you? Okay. All right. Now, so somehow we have to know those words. Perpendicular bisectors meet at the, can you fill them in? Circumcenter. Medians meet at the centroid. Altitudes meet at the orthocenter. Angle bisectors meet at the in-center. So here's what you should do. Every time you come across this question when you're reviewing, especially if it's a multiple choice, you should just make a little review chart for yourself. So the centroid medians. That to me is 2E. That's how I remember that. Centroid medians, second letter is E. Circumcenter is the perpendicular bisectors. The in-center, AB, keep your abs in, angle bisectors. Orthocenter, altitudes, two T's. Orthocenter, it's the intersection of the altitudes. Okay, all right. Now, since AE is congruent to BE and AF is congruent to FC, and this is congruent here, that means these points are midpoints. And so what is a segment that's drawn from a vertex to the midpoint? What is that segment called? It's a median, right? Median, vertex to a midpoint. So point P is the centroid. Okay, now, do you know the relationship of the lengths with the centroid? They didn't ask about it in this question, but they could. Yeah, it's 2 to 1. So this length is double that length. So it's in a ratio of 2 to 1, the ratio from the vertex to the centroid and the centroid to the midpoint. Okay. All right, last one. For a triangle, which 2 points of concurrency could be located outside the triangle? Okay, here's how you can think about it. Which one makes the most sense that it should always be inside? Good, okay. So the question is, what's the other one that's always located inside? The centroid, yeah, we look at this, there's no way. The centroid is actually the center balance point. If you were to try and balance that triangle, that would be the balance point. So therefore, it's not in center and centroid, it's not centroid, it's not the in center. So number 4 is here. Okay, bonus question. Which type of triangles do they have to be for those points to happen on the outside? Close. Obtuse. What would happen if it was a right triangle? Where would they be on it? Okay, so in, on, out. All right. Good work.